Welcome back to the Python programming specialization. So in the last video we have seen how to create the ND arrays using the Numpy package in Python, right? In this video, how we can access the elements from the ND arrays. That is, once the ND array is created, so we need to access the elements, that is retrieve the elements, right? Then how it can be done in the Numpy. So that's what we'll be discussing in this video. Basically the elements in the Numpy n-dimensional arrays are stored in the contiguous memory locations. So it is possible to retrieve the elements from the ND array using the integer indexing. And in this lecture we'll see in detail so how indexing can be used to access especially the 1D arrays and the 2D arrays in detail. Once you understand these two, then you can extend this to any dimension arrays. Now let's see how to access the elements from the 1D arrays. So we'll see how to access the elements from the one-dimensional array objects, two-dimensional array objects and the three-dimensional array objects. So if we understand the accessing of elements from 1D, 2D and 3D array objects, in the similar manner we can access the elements from the higher dimensional array objects also. So now let's see how to access the elements from the 1D array objects in Numpy. To access the elements from one-dimensional array objects, you can use the integer indexing. So whichever elements you would like to access, those indices you need to pass. We can use the integer index values to access any of the elements from the array objects. To access the elements from the 1D arrays, so we can use the single integer index to access a specific element. The indexing in the Numpy array starts with 0 and ends with the number of elements in that dimension minus 1. So consider this array which is having a total of 11 elements in the array A1. So here this elements index is 0, this elements index is 1, 2, 3, so on and so forth. The last elements index is 10. So as the elements index starts with 0, the index ends at the number of elements minus 1. So to access the first element in this array, I can use the index 0. I can use the index 5 to access the element at the 6th position. So and I am using the index value 10 to access the last element from the array object A1. So now you can use the single index to access any specific element from the array object. As you all know, Python supports the negative indexing also to access the elements from the array objects. In case of the negative indexing, the last element of the array can be accessed using minus 1. So then this value minus 2, minus 3, so on and so forth. So this element can be accessed with minus 11. So here you can see the examples. So A1 of minus 1 is returning the last element from this 1D array, and A1 of minus 2, the last but one element. Similarly, A1 of minus 3, you can access the value 9, and A1 of minus 11, it can be used to access the first element of your list. This is how you can use the negative indexing to access the elements from the 1D array. This is how you can use the negative indexing to access elements from the array objects. So now let's see how we can use slicing on the one-dimensional array objects. So in these cases, whenever we are using simply index value, we are accessing only one specific element. But to access multiple elements or to access a sequence of elements, then how we can do that is we have the slicing option to access a specific portion of the array. The slicing operator works in similar way how it works in the standard Python. So say for example, I would like to access the elements from the index 0 to index 4. Then how do I do that? So you can use the slicing operator. So it should start with 0 and ends with 5. These two values that are used with the slicing operator represents the starting index value and the end index value. The element at the start index value is included, but the element at the end index value is not included and it is excluded. That is how when you are using 0:5, the element starting at the index 0 is retrieved, but the element at the index 5 is not retrieved. The elements till the index 4 are only retrieved using the slicing operator. So this is how we can use a slicing operator to access a portion of the elements from the array objects. So now look at this example. We are using 4:9, so which retrieves the elements at the index 4 to the index 8. You need to remember that the end index is not included, it is excluded. It is also possible to use the step counter along with the slicing operator. When the step counter is not used, then it is by default set to the value of 1. That is how we are getting every element, that is with a step counter of 1, we are getting all the elements within the given range. So consider this example where I am setting the step counter to 2. When we set the step counter, what happens is within the range, all the elements with this step counter are retrieved. So in this example, all the elements within the ranges 2 to 7 are retrieved with the step counter of 2. The values that are retrieved from the index 2, 4 and 6. As the end index is not included, will not get the value at the index 8. So that is how we can use the step counter to specify the interval between the elements that we would like to retrieve. You can even ignore the start and end indices also. So when the start and end indices are ignored, then it indicates all the elements have to be retrieved from the list. Consider this example where I am not using any start, end and the step counter. That indicates I am retrieving all the elements from the array object A1. You can even ignore one of the start, end or the step counter values. So if you ignore both start and end values, then that means all the elements. But when you set the step counter value, all the elements are retrieved with the specified step counter. If you observe here, all the elements are retrieved but with the step counter of 2. That's how from the original list I am getting the values at the index 0, 2, 4, 6, so on and so forth till the last element. And consider this example where I am ignoring the start index. When the start index is ignored, by default it is set to 0. So that is from the beginning till the 9th index all the elements are retrieved. But as you are mentioning the step counter, so with that step counter all the values are retrieved. And it is also possible to ignore the end index. When the end index value is ignored, then by default it is set to end. That indicates till the end of the list. So here in this case 5 colon, we are ignoring the end index. That means all the elements from the 5th index till the end of the list, they are retrieved. Because we are setting the step counter as 2, so with an interval of 2, all the elements from the 5th index are retrieved. And it is also possible to use the negative values as the step counters. So when we use the negative values as the step counters, then elements are retrieved in the reverse order. It is very easy in Numpy or in Python to get the reverse of the given list by setting the step counter as -1. When you do not provide any start and stop values, and if you provide the negative step counter, then that list retrieves the reverse of the given list. So even for the start and stop values also, we can use the negative indexing. So in this case, we are retrieving from the index -4 till the index -1 with a step counter of +1. So -4 means this is -1, -2, -3, -4. That's how from this index to this index, all the elements are retrieved. So now we understand how to access a specific element or the portion of elements, or by using the step counter, how to retrieve elements from this one-dimensional array we have seen. Now you understand how to index the elements from the 1D arrays. Now let's see how to access the elements from the two-dimensional arrays. In case of the two-dimensional arrays, the elements are arranged in the form of rows and columns. So you can either use a single index to access a specific row, or you can use both the index values to represent the specific row and from which specific column you would like to access the element. So you can mention that with the help of both the indices. So now let's create a two-dimensional array which is having 4 different rows and 10 different columns. So you can have a look at this array object A2, which is a two-dimensional in nature. So now to access a specific row from this array object, we can use the row number. So in this case also, the indices always starts with 0 and ends with the number of dimensions -1. For example, in the array object A2, so there are 4 rows and 10 columns. The index starts at 0. This row indicates the row at the 0th index, the row at the first index, second index and the third index. And similarly, you can see here, so the column at the 0th index, first index, second index, so on and so forth, the 9th index. So to access the first row, you can pass 0 as the index to the array object A2. So it retrieves the first row from this array object A2. And similarly, to access the second row, you can use the index 1. So now let's see how we can access a specific element from the two-dimensional array object. Say for example, I would like to retrieve the element 30. In that case, I can pass the row number as 1 and the column index as 2. So by passing the row and column indices separated by comma, I can access a specific element from the two-dimensional array object. Say for example, I would like to access multiple rows. How do I do that? So I can use a slicing operator. So here 1:3. So it retrieves all the rows indexed at 1 to 2. So remember, you need to remember the end index is always excluded whenever you are using the slicing operator. That's how the row that is indexed with 1 and the row that is indexed with a 2. Both are retrieved in this case. And how do you access a specific column? Accessing the column from a two-dimensional array object is little tricky. So you need to pass the first dimension as colon, which indicates all the rows, and whichever column you would like to access, that column number you need to pass. Here in this case, I am passing colon comma 1 that retrieves the element at the index 1. So it retrieves all the elements from the index 1. It is also possible to access specific columns from the array object. To access the columns from the index 3, 4, you can use the slicing operator with 3 colon 5. And to indicate all the rows, you have to use a colon operator at the row position. Now, how do we access specific elements from the two-dimensional array object? So far we have seen how to access the columns and rows from the two-dimensional array object. Now, I would like to access this portion, say for example 20, 30, 21, 31. So these 4 elements I would like to access. So how do I do that? So I can do that by mentioning which rows you want to access. So here in this case, the first row to third row I would like to access, and coming to the columns I would like to access the first column to the third column. So this will retrieve the specific portion of the elements. It allows you to retrieve the elements which are spanned across the rows and columns from the 2D array object. Now I hope you understand how to access elements from the two-dimensional arrays too. So the same way, however, we are doing the accessing of the one-dimensional arrays and the two-dimensional arrays, the same can be extended to the multi-dimensions, even any dimensions of the Numpy arrays. Now let's see how we can access the elements from the 3D array objects. So consider this 3D array object, which contains a 3-dimensional array object which is of size 3 by 3 by 3. If you use a single integer indexing to access the elements, then it allows you to retrieve the first element of that matrix, which is a 2-dimensional array object in this case. And if you want to access the last element in the 3D array object, you can use the -1, which retrieves the last element from the 3D array object, which is actually a 2 by 2 array. Now to access the first element, you can use A3 of 0. To access the second element from the 3D array object, you can pass A3 of 1. So if you observe in this case, A3 of 0 is retrieving a 2-dimensional grid from the 3-dimensional array object. And from this 2-dimensional grid, again, I would like to access only the first row. Then how do I do that? I can pass the index of that specific row so that I can access that row alone from the 3-dimensional array object. And from this 4, 5, 6, again, I would like to access the first element itself. Then how do I do that? I need to pass 3 index values, where the first index represents here you can observe that A3 is a 3 by 3 by 3 array object, and with these values. So if you pass all the 3 index values, then what happens is the first index allows you to access the element from the 0th dimension. Then the second index allows you to access first element from that specific object. So from this element, so what is the value that represents the first index? The index 1. Then from this specific element, I would like to access the 0th element, that is 4. So that is how you can access a specific element by passing all the 3 indices to the 3-dimensional array object. It is also possible to use a slicing operator with the 3-dimensional array object, which allows you to access the elements that are spanned across the multiple dimensions. So far in this lecture, we have discussed how to access the elements from the Numpy ND arrays. So we have seen in detail with examples how to access elements from the one-dimensional arrays, two-dimensional arrays, even with the multi-dimensional arrays also. So now I hope you understand, and you will be able to access the elements from the n-dimensional arrays with ease. Thank you for watching this video.